Okay, welcome to the poster sessions. My name is Zeng. I'm from Utah. Let's look at this image. You got something you don't like. What's the easiest thing you want to do to remove it? Apply a filter. Okay, but filter noise. Noise and artifacts are two different things. Can we treat artifacts as noise? See poster number 1.
So, hi everyone. I'm Joaquim Sanctorum from the University of Antwerp. And my research is about multi-exposure techniques to overcome issues related to the limited dynamic range of your imaging system. So when the properties of your object of interest are beyond the scope of the dynamic range, you will get some issues. So if you want to know what those issues are, how these multi-exposure fusion methods work, and how we can give them like a quality score, please visit the poster number 2. Thank you.
Hello, my name is Tobias. I'm from Munich in Germany. I'm presenting on behalf of Erdal. Maybe you remember the presentation on Monday with a very cool CT system with the robots, 2 Kuga robots. Well, our system isn't as cool. We only have 1 robot, but it allows us to do arbitrary acquisitions. And if you want to find out how we actually make it work, because the robots are not as precise as we would like them to be, please come to poster W3. Thank you.
In this poster, we propose a generalized TV-based regularization model for limited angle CT, in which the panelization of image gradient for each image pixel is adaptively adjusted by a pixel-related weighting matrix. The model is solved by alternately performing SART and GTV minimization. The experimental results illustrated in figures show that the GTV method has more advantages than the SART method, the AEDS method, and the GTV method in reconstructing tailed edges.
Hi, I'm Yirong from Stanford University. We will present our work in comparing material decomposition performance of 4 different energy beam compression strategies for photon counting detectors. The result from our simulation study show that we can reduce 8 energy beams to 2 weighted sums, where the continuous weights give the best performance with high compression ratio, low noise penalty, and no additional bias. So if you're interested in that, come and visit poster W5. Thank you.
Motivated by the success of GTV model to explicitly encode with the visible algebra in the model construction, the GTV model is reformulated. By treating the X direction regularization different from the Y direction regularization, we think that the visible algebra could be better utilized.
Dear all, currently very few publicly low projection data available to simulate pair training data due to the commercial confidentiality of city vendors. Moreover, existing denoising models are usually only applicable to a single dose level and performs worse at lower doses. Therefore, we propose a dual test learning network for low-dose CT simulation and denoising, which uses a joint discriminator to optimize the simulation and denoising network by learning the joint distribution of LDCT and NDCT data.
Good afternoon, everyone. I'm presenting on behalf of a friend in China. Basically, we investigated a statistical iterative reconstruction method for photon counting CT. Specifically, a Gaussian mixture model is utilized to model the complex noise distribution in photon counting CT image domain. Meanwhile, a 3D total variation regularization term is also incorporated into the object function. If you are interested in this work, please come to our poster number 8. Thank you.
Hello, everyone. My name is Dennis. I'm from the Royal Institute of Technology in Sweden. The topic of this poster is the ring artifact correction in photon counting spectral CT using deep learning. In particular, we formulate this problem as learning a map F, which maps a pattern of ring corrupted material basis images to the ring artifact tree counterpart. And we do this using a unit and a perceptual loss function. If this sounds interesting, please stop by poster number 9. Thank you.
Hi, everyone. I'm Xiaoyu from UT Southwestern. In our lab, we have the photon detector, and we also have the small animal irradiation platform. And then we Lego them and play with them. When playing with them, we are allowed to specify many energy thresholds. So we propose a simple and experimental way to select and optimize these energy thresholds. Of course, we have some results. So to tell all stories about these slides, I will be at the 10th core. Thank you.
My name is Ken Sauer. I'm part of a team that's attempting to use deep learning to remove some of the damage from low signal in diagnostic X-ray CT. And given the specificity of the application, we feel there's a lot of room to do creative penalization in the training phase. So come to number 11 if you'd like to talk about it.
Hello, my name is Koen Michielsen from Radboud University in the Netherlands. I'm presenting a poster on behalf of my colleague Mikhail Mikerov, and we examined the effect of the choice of material decomposition in a polychromatic reconstruction algorithm and how that influences the accuracy of your iodine component. So if you're interested, please come and see me.
Hello, everyone. I'm Nora Steinich. I'm with Siemens Healthineers, and we've been working on a way to incorporate motion compensation into the weighted filter back projection algorithm in a way that also incorporates the rebinning method. For this, we assume that the motion is known either through measurement or estimation, and we also incorporate it into two different versions of the iterative weighted filter back projection algorithm. So if you want to find out more, please find me at poster 13. Thank you.
This work, we use a modified CT scanner suited for high-density materials, where an in-house reconstruction algorithm is used. We explore two different back projection techniques, Sidon-based ray-driven and voxel-driven with bilinear interpolation. The convergence trend of the algorithm using an unmatched projector-back projector pair is shown with a virtual phantom. For small samples, iterative reconstruction of the ROI and voxel-driven back projection produce sharper images with reduced location-induced blurring.
Hi, my student Marion Savanier has developed a strong interest in all the flavors of total variation, and in this work she looked at directional total variation, that is enforcing the sparsity in one a priori known direction. So it can be interesting in an interventional setting where you have percutaneous intervention. But then when you have a background, the background does not fit that a priori. So she developed a decomposition method to separate the background from from the needles. So if you are not interested in seeing the result, please enjoy the weather.
Hi, everyone. We present a new methodology for tomosynthesis reconstruction that tries to retrieve tomographic information based on a deep learning approach. The input images are preliminary FDK reconstructions, and the target images are CT scans. We use UNet network with ResNet34 as the encoder pre-trained with ImageNet. We incorporate 3D information by alternating coronal and axial slices in the training strategy. The results show a realistic demographic texture. Thank you.
Hi, I'm Fatima from the Otto von Guericke University in Magdeburg, Germany. Introducing some depth information with relatively low dose and requiring less space in the operating room, digital tomosynthesis is a potential candidate for guiding interventions. In this context, we have recently proposed a new spherical ellipse tomosynthesis scan trajectory suitable for interventional bronchoscopy procedures. For a further improvement of the image quality, and given that often prior CT scans are available prior to interventions, we propose in this work a prior-based intraoperative tomosynthesis reconstruction framework. If you are interested and would like to know more, please visit my poster number 17.
Hello, everybody. So this work is on X-ray scatter estimation and tries to solve a problem that we often have with existing approaches. That is that you need a lot of prior knowledge to derive accurate results. So for instance, if you think of Monte Carlo simulations, you need to have access to the X-ray spectrum, object scattering properties, and so on. So to avoid the necessity to determine all of these parameters, you may stick to our approach that uses a deep neural network that can be trained in a completely unsupervised manner to derive accurate scatter estimates. So if you're interested in the details, please see me at poster 18. Thank you.
Hello, I'm Peter. I will present an originally formulated iterative reconstruction algorithm based on statistical model for flying focus spot tomography. This method is dedicated especially for low-dose CT scanners. First view we receive in less than 10 seconds. So if you would like to know why it's so good and fast, please ask me. Poster number 19.
Hello, I'm Sasha Gasquet from the University of Grenoble and Chama. On the left picture, you can see a multiple linear detector system with a single X-ray source. On the right picture, you can see a phantom built with opaque segments. In our poster, we propose several calibration methods and phantoms to calibrate simultaneously such systems. You're welcome to come by to my poster number 20.
Hello, my name is Sumin Baek. I'm visiting from Teasers in South Korea. Our poster is about liver vessel segmentation in photon counting CT using deep learning. We generated multi-channel datasets by utilizing the characteristic of energy discrimination capability of photon counting CT. We injected iodine agents into the liver vessels, and we used 3D unit segmentation, 3D unit network for segmentation. We found that the segmentation using photon counting CT outperformed the segmentation using conventional CT. Therefore, using the photon counting CT would more likely improve diagnosis and management of liver vessel. Thank you.
Hello, my name is Andrei. I'm from Carl Zeiss microscopy, X-ray microscopy. So yeah, in this work we revisit what now is like classical beam hardening and / metal artifact correction algorithm. Here we spend some effort to like propose workflows that can make it a little more kind of automatic without need for manual parameter tuning. We also note there is also some necessity to perform optimize it more on sub-volume basis rather than try to perform global optimization. Yeah, please stop by. Thank you.
Hi, I am Zhang Hyun-nam from Digest. The normalized metal artifact reduction method needs a good prior image to properly normalize the original sinogram. I present today the simple method to combine the deep learning method and the NMAR method to generate the better NMAR results. Thank you.
Hi everyone, Prabhat from the FDA. In this work, we are interested to quantify improvements achieved by deep learning-based CT denoisers after augmentation. In this work, we consider computer vision-inspired augmentation as well as augmentation from CT physics-based noise insertion model. And for error analysis, we consider global metrics, CT bench test, as well as low contrast detectability-based task assessment. For more info, come to poster 24. Thank you.
One more.
To improve the quality of reconstructed image for spectral CT, we propose a reconstruction algorithm based on a joint multi-channel total generalized variation minimization and tensor decomposition. This algorithm makes full use of the sparsity of the image and the same physical structure of the image and different energy channels. Experimental results show the effectiveness of the algorithm.